Welcome to the lesson Newton's Laws of Motion. We are going to do questions and discussions, and this is your presenter is Mr. Aseto. Question 1. What is force needed to stop 500 kilogram car moving at 180 kilometers per hour in 12.5 meters? Let's see how that question can be handled. We have got the logical analysis. The mass of the car is 500 kilograms. Initial velocity, or the car was moving at initial velocity of 50 meters per second. And the distance to be covered or to be measured before the car stops is 12.5 meters. The final velocity is 0 because the car comes to rest. So that's the way the car will move. Then velocity is there, the distance is there, and then now we can now work out velocity squared is equals to u squared plus a half at squared. That means acceleration can be found from that equation. V squared minus u squared over, what is your prediction? 2s. If we rearrange that equation, that's what we'll have. We can be able to calculate acceleration. The acceleration, therefore, is equals to 0 squared over 2500 divided by, that is 0 squared minus 2500 divided by 2 times 1, 12.5. And you get acceleration as negative 100 meters per second squared. It is negative because the speed is reducing constantly, or the vehicle is retarding. So that is retardation. So that is, therefore, the force that is needed to stop the car would be given by the Newton's second law of motion, which states that F is equals to ma. Now we have mass, we have got acceleration. Now from that, we insert the value 500 kilograms times 100, negative 100 meters per second square. Then we get negative 50,000 newtons. So that is that. You can be able to use that to handle this question. An apple of mass 100 gram falls a distance of 2.5 meters to the ground from a branch of tree. Calculate the speed at which it hits the ground and the time taken for it to fall. Please ignore the air's resistance. Calculate the momentum of the apple just before hitting the ground. Let's look at impulse force. Impulse is force times time. When an object hits another one at a given time, a fraction of time, the force it hits that object and the time it took is called impulse. From the equation of, from the second law of Newton's, or Newton's law of motion, we know that F is equals to change in linear momentum over time. When we multiply both sides by time, then we get force times time is equals to change in linear momentum. So impulse is also equal to change in momentum, mv minus mu. So in the question, I want you to determine the change in momentum produced when a force of 400 newtons acts on a body which is at rest for 0.003 minutes. I want you to do that question. Remember, logical analysis is important. You start with logical analysis, what is given in the question. You list them and what is asked. You must list what is given. For example, we are given force and we are given the minutes. That is time. So we look for the connection between the force and the time. So that would help you to understand how to solve the problem. Determine the change of momentum. Remember what is change in momentum? For Newton's third law of motion states that for every action there is equal and opposite reaction. That means if you have a table and an object of 40 kilograms on the table, 40 kilograms is equivalent to 400 newtons. Therefore, the action on the table is 400 newtons. The reaction which is distributed on all the support of that table equally, if the object is at the center, is the total sum that would give us 400 newtons. So if we work it out and we assume that all the reaction of forces on all the support of the table are equal, then the total sum of the reaction of force must be equivalent to the mass times gravitational acceleration, which is the weight. Newton's third law of motion still applied. We can find its application in the lifts. When lift is at rest, the total upward force, which is the reaction force, is equals to the total downward force, which is weight. So R is equals to mg. When the lift is moving down, the resultant force is equals to the downward force minus the reaction force. The resultant force is ma. So therefore, ma is equals to mg minus reaction of force. So the reaction of force is equals to mg minus ma because the object is going down. You can be able to see that. So when the lift is moving up, the resultant force is equals to upward force minus downward force. Therefore, resultant force is equals to ma, as we know. ma is the reaction force minus mg. Therefore, the reaction force is equals to mg plus ma because the object is moving up. You can be able to see that. So question 4. A man of mass 80 kilograms stands on a lift which is accelerating upwards at 0.5 meters per second squared. If G is 10 newtons per kilogram, determine the reaction on the man by the floor of the lift. Again, we have to look at the logical flow of this question, and starts with the collection of data. Mass is 80 kilograms. Acceleration is 0.5 meters per second squared. Gravitational acceleration G is 10 newtons per kilogram. So we are supposed to determine the reaction force R. So in which direction is this motion? Upward. And what did we say about upward motion? The reaction force is equals to upward acceleration. What did we say? We can go back there and see. So the force that is making the object to go up is the difference between reaction force and that. So R is equals to mg plus ma. So you are given mass, you are given G, which is 10, that is 800